the types of intermolecular forces that exist are going to be dependent on the type of compound that you have. Now, what's common is that all intermolecular forces are dependent on what's called the Coulombic interaction, and that's the energy associated with the electrostatic force. Okay, you know, there's potential. This is the potential energy associated with electrostatic force, and it's going to depend on where you are within an electric field. And it's very analogous to if you think about like the gravitational force and gravitational energy, potential energy. It's distance on it's dependent on the gravitational force is dependent on the mass of the object and how far the two objects are away from each other. You know, the distance. And that's the same is true for the electrostatic force. And electrostatic force is the dominant force on the scale of atoms, molecules, and ions. So anyway, this you don't have to memorize this equation. I just put it here. Q stands for charge. So Q1 and Q2 would be the charge of the two species. So the magnitude of the charge. Okay, so the bigger the charge is on your species, the stronger this energy is going to be, the stronger the attraction. And all this stuff down here just depends on, these are just kind of constants. The thing that you want to focus on here is R, and that's the distance between the two species. Okay, so the force, an electrostatic force depends on how big the charge is and how far apart the charges are from each other. The bigger the charge, the bigger the attractive force. Okay, and the closer, the shorter the distance, the bigger the force. Okay, so distance and charge are what we're looking at here. And so depending on the magnitude of the charge and how close these species are to each other, that's going to say, you know, how tightly they stick together, basically. And so these intermolecular forces are responsible for all condensed phases of matter. That's how discrete particles stick together. And there's different strengths of the forces. The ion-ion is the strongest type of force. That's why we even call it a bond. And then the dipole-dipole is the middle. And so dipole-dipole means that there's that there are two poles. So it'd be a polar species. And then the weakest is called London forces, and I'll describe that. That's the only kind of force that exists in nonpolar species. I'll describe it in detail later. But for now, I just want you to know that there's different types of intermolecular forces, and they have different strengths, and they all depend on the charge and the distance. Okay, and then hydrogen bonding, you already saw that, and you've heard of it a lot before in biology and whatnot. It's a special type of dipole-dipole, so it falls within this category of dipole-dipole, because if you have hydrogen bonding, you're going to have an extremely polar molecule. All right, so we use these intermolecular forces. If there were no intermolecular forces, everything would exist as a gas. Okay, so in order to exist as a condensed phase, these little balls are modeling. They're not like little balls. They're modeling little atoms within a condensed phase. And you know, if it's water, it's just kind of like all jumbled around. But they are touchingly close to each other because of this attractive force. And then the solid, they're showing a crystalline solid. Okay, it's the intermolecular forces that hold these together, these species together. All right, so that's the end of part 1 of this chapter, or excuse me, lecture 10. And then I'll follow on with describing each of these different types of intermolecular forces in part 2 of this lecture.